So 1A, who can tell me what that function notation is saying in context? Wade.
In 2017, 2.32 billion people own a smartphone.
In 2017, 2.32 billion people owned. I don't think there's an E there. Owned a smartphone. Well, so it is billion because it's 2,320 million. So that's exactly what that says. Who's got B? What does B say in context? Gonna go for it, Cam?
Yeah. In 1990, smartphones were invented.
In 1990, Mr. Mac was 4. And there were no smartphones. Yeah, I was born in 86.
My mom was 8.
Number 2, use function notation to represent these statements. So who's got a function for me for 2A? Mia. There we go. I got you. Yeah. It says in million. Oh, wait, that's not right then. It says in millions, and that's 296 million. So that's 296.6. Okay? So that says 10 years after. And George.
P15 equals 1.86 billion.
Oh, wait, this is in millions, though.
Oh,
Right?
so 100.
No, 1,000.
1,860 million. So that's just the challenge there is like changing units essentially, right? But P of 15 says the function of 15 or 15 years after 2000. And then the 1,860 tells us in that year. And that number should be a little lower, wouldn't you think, than 17 years after? So if we reference 1A, that makes sense. That's a little lower. Okay. Cool. May is curious. When was there 1,000? So how could we figure that out?
Figure T out.
How could you figure out the year that there's 1,000?
Look on the graph.
I think we need the graph, right? But it's saying to test out 4. Do you think 4 would work?
No.
Why not?
Maybe.
Well, yeah, Elijah, why not?
So let's say that. Do you think P of 4 can equal?
No.
Well, here's a good reference point.
If 10 years later there's only 290.
6 years later, there were fewer.
And it's going.
You guys see what I'm saying? So it doesn't make sense. It's probably going.
Throw away their phones and not pick them up.
So that probably doesn't work, right? Is it possible? I'm going to say probably not. Okay? Because after that, it was lower than that. You guys seeing that? Okay. Now it's time to get sketchy.
Well, what about A? We didn't.
Oh, sorry. We said it would tell you at what year, right? At what year there are 1 billion cell phones. Well, smartphones, but yeah, you know what I'm saying. Okay, number 4. Let's put down some of these points we know. So 10 years before, there were none. Okay, what are some other ones we know? What's the next up?
10 years
P10, there's almost 300. So at 10, there's like right here.
Where are you on?
I'm graphing this thing. I'm making those little dots. P15 is,
Wait, where did you just put that one in here?
1860 at P15. And that's going to be right about here, ish. And then what we had, P17? 2320. 2320 is going to be right about somewhere in there. Ish. Do I have another year? That's all the years.
1,000.
And that's good. Cool. It's a little sketchy. So it increased pretty significantly here, wouldn't you agree?
Yep. Yeah.
We went from nothing to like seeming to be a lot. It does seem exponential. Exponential has to be kind of perfect, and we will talk about exponential functions later this year. So I just put dots down for input outputs I knew. Okay? Now, remember we talked about discrete versus continuous. Dog barks were discrete yesterday. Continuous was distance the dog walked. Do you think cell phone ownership would be continuous or discrete? Can you?
No, eventually it'll plateau because.
Well, that wouldn't change continuous or discrete. Continuous would be like we connect everything.
Oh.
Discrete would mean like we have dots for all the cell phones. What do you think? Mia? Continuous or discrete? I got a question for y'all. Can you own part of a cell phone? I mean, you could, but then it wouldn't be functioning. So it's going to be whole cell phones. Now, at a scale like this, let's say we put down each individual cell phone's point. What would it probably look like?
A lot.
It'd probably look like a line because that scale is so big, you'd have to make like so many teeny little dots for each cell phone. So someone might portray it as continuous on a graph. It also is nice for seeing a trend, but practically speaking, would we be speaking to partial cell phones? No, so it's technically a discrete situation, even if someone drew a continuous graph. Okay. So next, we've got a function in temperature. Before we get going, if we've got temperature and time, what do you think's the independent variable?
Time.
So you're telling me that the temperature outside doesn't change what time it is inside? That'd be cool though, but it doesn't. So independent is time. What depends on the time? Temperature. Okay, and this is in degrees Fahrenheit of a pot of water on the stove after the stove is turned off. After the stove's turned on. So with your partner, you're going to explain the meaning of all these function notations and then plot what you know as a possible graph. Who can interpret what W of 0 equals 72 means in context? Deegan.
At 0 minutes.
Whoa. That's not you, that's me. I got Deegan, okay.
The water is at 72 degrees Fahrenheit.
At 0 minutes, water is at 72 degrees. So I'm going to put that on here, right? 50, 72 is right about there. No, that's not. 75, yes, I'll take it. So that means like I'm interpreting that as water went on the stove at room temperature. 72 is room temperature-ish. And let's say at my house, we're at 66 trying to save some money. Noah, what does 2 mean? Or B?
Means that after the water's in the stove for 5 minutes, it is warmer than the water in the stove for 2 minutes.
At 5 minutes, it's hotter than 2 minutes. Okay. So, like, I don't know how hot it is at 5 minutes, so I'm going to chill on the graph still for a little bit. Charlie, what does C tell us?
Well, after 10 minutes, the water is 212 degrees.
At 10 minutes, water is 212. So,
That doesn't have one. There's 6 of them.
oh, I'm missing one. Okay, so I'm going to go like right there. That's what I know so far. And I'm actually going to draw a line because does this satisfy B?
No.
Is it greater at 5 than 2? Yeah, that satisfies B. We're good still. Okay. D. What does D mean? Mia.
At 12 minutes.
Oh, yours is different. Let's add yours. Yeah, let's add yours. Yours has one more than mine. Say your D is different than my D. Say yours.
At 12 minutes, temperature is
At 12 minutes, temperature is what?
it's equal to 12. Wait, no, 12. Both at 10 minutes and 12 minutes.
So if it's equal at 12, 12 is equal to 10. What is it at 12? 212. So that means I go flat there for a second, right? Okay. For more room, I'm just writing down here. This one, the next one. W of 15 is greater than W of 30. What does that mean in context? Alden.
The water was hotter after 15 minutes than after 30 minutes.
So water is hotter at 15 minutes than 30 minutes. Okay. So I know it's going to trend down. Okay. And then E, what does E tell us? Yeah, Sebastian.
That at 30 minutes, it is warmer than it is at 30 minutes. That means
At 30 minutes, it's hotter than
above 72, but less than 2.
Okay. So at 30 minutes, it's warmer than it started, but it has to go down. So we're not going to go to a specific point over here. I'm just going to pick this point to go to, but it could be any point as long as it's higher than 72, right? And so here's a possible, it says possible graph. You could have went down lower, you could have went up a little bit, but really, who can just describe in general in this situation now what happened on this stove? Like a little play-by-play. John Madden, this thing. Charlie, what do you think?
So the
water started at 72 degrees,
Yeah.
and it quickly rose up to
How?
212.
What happened?
The stove got turned on and heated up.
They turned it up.
And then
Okay.
it peaked at 212, plateaued for a little bit, then declined.
Why do you think it stopped at 212?
Maybe the stove turned off.
Because that's the boiling point.
Boiling point.
Oh, that too.
Unless you have pressure or you live somewhere else, can you get hotter than that?
Not really.
I say live somewhere else because air pressure deals with boiling point a little bit. But yeah, you can't. So boiling, you can't get hotter than boiling because the water gets rid of all the energy, excess energy of steam there. There's your science lesson for today. And then they turned it off, you're saying? Or turned it down significantly, maybe? Turned it to a simmer? Where did I have it ending? I ended at 100. 100's not a simmer. They just threw some ice in it. So technically, it could have went down real quick and then plateaued. We don't know if they threw ice in there or not. That's really the unknown. We were all wondering it, but it's the unknown.